How's everybody doing? Enjoying PowerShell Summit? This is one of my favorite events. Also, I have a terrible allergy problem today, so I'll try not to cough on y'all. It's been a rough day. Cool. But you don't care about that. You care about Kubernetes. So we're going to talk about deploying applications in Kubernetes Windows Edition, because I talk a lot about deploying applications in Kubernetes, but never in Windows, and you're going to learn why. So I'm Anthony Nocentino. I'm a principal field solution architect at Pure Storage. I've met most of y'all over the last 24 hours and known some of y'all for many, many years. That's my contact information. I'm on Twitter a whole bunch. I have a blog, which recently has relocated real estate to nocentino.com. I also have a GitHub repo, which is where the code for this is. So if you want to sit in the back and you can't read the code, I'm sorry, but you can go get the code and download it and read it line by line. I'll read the line numbers to you. I'm a Pluralsight author. I have a ton of content out there on Kubernetes, containers, Linux, things like that, PowerShell, Linux, super fun stuff. And I'm a co-organizer of another really awesome event. Wrote a bunch of books, MVP, fun stuff, but we don't care about that. We care about all the cool technical stuff that I'm about to get into. First off, I'm gonna start with a story, because what I'm gonna teach you today, or talk about today, it was like real life stuff that I had to deal with at a customer site. Before I worked at Pure, I was an independent consultant for 10 years, working on SQL Server workloads and Kubernetes workloads. And so we're going to do a lot of stuff today. The tech bar for this conversation is very high, but what I will promise you this is the code is completely reproducible. So you can take the code home and run it line by line, and you'll be able to do what I've done today. Okay? But I wanted to get the whole story in front of you today. So when I am going through the code, I don't want you to focus on each line of code, but what I'm actually doing in that code, okay? For example, like we're going to deploy AKS. Well, that takes time. And I don't really want to spend a bunch of time talking about that code, but talking about the process, right? We're going to build a container on a Windows-based application. We're going to deploy a Windows-based container inside of Kubernetes. We're going to roll out that container into Kubernetes, a Windows-based application, and then we're going to compare and contrast Linux and Windows containers. I'm not here to tell you one is better than the other, but I'm here to tell you one of them is they're situationally appropriate for what you're trying to do, okay? And then we're going to talk about some best practices and life lessons, right? And we're all going to sit around and maybe do fun things. So the story. So in 2019, I had a friend of mine sent me a referral to a customer that had an application that they were rolling out in Kubernetes. And they were like, we roll our application out, and every time we roll the application out, it goes down. And customers are sad, we're sad, nodes are crashing, things are going wrong. And 40 minutes into the conversation, I realized that they were running on Windows containers, because I was like, you know what? You use Windows containers, you're the only ones, right? Because at the time, it was 2019. I was in Vegas, I was hanging out with my wife, and I'm helping this customer get through this downtime thing, taking advantage of the time zone. It was like 4 in the morning Vegas time. And it took me that long to figure out that they were running in Windows nodes, because nobody did at the time, right? Especially because AKS, Azure Kubernetes Service, was in public preview. So when they called Microsoft, what did Microsoft do? They're like, that's cool, right? Because they had problems when they rolled out their application. And that's what today's talk is about, is what happened when they rolled out their applications. Who knows what Kubernetes is, roughly? Awesome. All right, then if you know what Kubernetes is, you know what a container is, right? Who's built a container before? Awesome. Okay, cool. About half of y'all. Don't worry. I'll walk you through the whole process. But the idea that we're going to see today is this company had a traditional IIS application that would go literally on an IIS web server. They put it in a container and they tried to roll it out in Kubernetes. Who's deployed an application in IIS in their career? All right. What's the first thing that happens when you hit an IIS application in a traditional Windows server? Right, and how long does that take? Right, it takes some time. And we're gonna learn how that's a challenge in the Kubernetes universe. And so let's talk about building containers. We're gonna build an image today, and an image is your code. It's the thing that you do, it's the execution environment for whatever it is that you wanna run. We're gonna take that image, we're gonna stick it in a registry. Today we're gonna focus on Azure Container Registry, right? You can have Docker Hub, you can use internal registries, but I get Azure credits because I'm an MVP, so it's free. We're going to use Docker files to build a thing. We're going to look at a Docker file to build an IIS-based Windows application. And so the process that we're going to do today is this. We're going to build an image from a Docker file that's going to make this container that we're going to take, we're going to build it and push it into ACR, right? We're going to do this, and then we're going to pull it down into AKS and run our application, right? This is like the coolness of running containers, because I can take this app and deploy it over there very, very quickly. Who's done this entire pipeline of building an app and rolling it out in Kubernetes? Cool, about 5 or 6 of y'all. Cool. All right, this whole session is demos. Unfortunately, the video resolution's not so great, so I encourage you to move up to check out the demos. All the recordings are also on GitHub too. That was weird push, but it worked. And so all of that's available there with all the code. So if you go to Nocentino or github.com, Nocentino/presentations, everything will be there. So the application that we're going to build, because I'm smarty pants, is a VB.NET application that's Hello World. So this simple Hello World application takes 20 seconds to warm up because it's an app pool. And so that's the first thing that I talked to this customer about. I was like, listen, you're on full.NET. It just comes with baggage, right? You can like do all the app warm up stuff and whatever it's called, the preload to cache and things like that. But really, if you want to move forward, you're going to have to replatform the .NET Core. That was the story, right? The ultimate thing that they really needed to do. And they did some technical analysis a few months before, and it was like 4 lines of code in their app that they had to change to get on the .NET Core. I'm like, let's do it. But they didn't want to touch that code. They had to fix the emergent problem, right? And so that's what we're going to talk about today, is all the tools and techniques that I use to help them roll out their application in its current state, right? One of the biggest things you have to be concerned about when you're working with Windows-based applications is base image selection. Who's built a Windows container? Is that fun? No. Because then you're like, I got to get this kernel to match that kernel with this version and that HP update 74.2 and match all those things together, right? It's not a pleasant process. So if you go to Docker Hub, which syndicates all the stuff from MCR, Microsoft Container Registry, you'll find a table that says this container works with these versions of Windows, which means your underlying nodes or your Docker runtimes where you're going to run and build your app have to match that. Or you have to do like process isolated containers or Hyper-V isolated containers. There's all this infrastructure around that. In comparison to if you do this on Linux containers, I just run a process, right? It's a lot simpler. There's a bunch of containers also to choose from. Not only do you have to be concerned about what kernel image that you're running, you have to, do I want to use Nano, do I want to use Core, do I want to use IIS, and there comes different reasons and different situations why you want to use each. So today we're going to use IIS because it's the worst case. It's 7 gigs. It's like me after COVID weight, right? So let's do it. Let's build some container images. And again, the screen resolution is not great. I should have thought that through a little better. But again, so if you've seen me teach before, what I do is every line of code, you can just highlight it and run it. Just like if you were doing something in SSMS to run T-SQL. And so the first thing that I want to do is for y'all, if you want to do this at home, is build your own development environment in Docker Desktop on Windows. And so that's the first part here, is installing Docker Desktop. So there's the installation instructions. If you're using Docker Desktop on Windows, you have to enable Hyper-V feature and also the containers feature. And that will allow you to create and run Docker containers on Windows. I have some nifty PowerShell that goes and downloads the binary itself from Docker via invoke web request. Install if you want to, but the key thing is this. When you're working with Docker for Windows, it's going to default to Linux containers. That should be a hint. But, but you can switch to Linux containers if you want to. And so that's what we're going to do right here. So you can run that code on line 18, or you can go over here, and you can switch, see how it says switch to Linux containers? That defaults to Windows, but I'm currently in the Windows state. So it says switch to Linux containers, which means I'm in the Windows state, which is really kind of weird. It's like multiplying by -1. And so before you do anything, and I always encourage folks to do this, before you do anything in advance, let's do the basic hello world stuff, right? Let's pull a container and run it. And so that's what I'm doing here on line 22, is I'm pulling a Nano container and I'm just running a command prompt because I just want to test the plumbing. When I did this and I built these demos, there were lots of 4-letter words used because at the time, I was in between builds. There was a bug with permissions and things like that. And I spent a week cursing at Docker for Windows. It was crashing and all those things. And then one morning, I finally decided to sit down and troubleshoot the problem. And 2 hours before that, the Docker developers pushed a fix. And so the whole thing was quite fragile. And I'm sad. And I like bourbon. So anyway, run the container. That's the first thing. Test the plumbing out, just a Nano server container. And I'm going to pull that Nano container. And it's going to pull down, and it's 103 megs, no big deal. Run that container, and the first thing you do is kind of like hello world, but just type hostname, move on, you've run a container, woohoo, right? Awesome. Remove that container. I'm going to pre-pull this container for later on, because this is the IIS image that we're going to build on. I sped up the demo, and you can see in the right-hand corner, like the clock is just chewing away. It takes 10 minutes to download and extract this container from MCR. Sounds great for a DevOps pipeline, doesn't it? So that container is going to be the base to our application because it's a full IIS server core LTSC 2019 image. And once that's pulled, that is 6 gigs, right? And in the universe of container images, that is Titanic, right? If you look at the other one, just the Nano core is 258 megs, and I have the one that we're going to work with, that's nearly 6. Not great. So that is our application, or our like just plumbing test to make sure everything works properly. So let's get back into, and of course I closed that screen. Get to see all of my personal effects now. All right, so let's move forward into the next part. So now I have Docker installed, I can run a container, right? It's a lot harder than it sounds on Windows. But the next thing that we're gonna do is deploy an Azure container registry, which is where we're gonna build our custom container locally and push it into ACR. And so what I have here is the code to do that. And again, focus on the concepts, not the code itself. So I'm gonna log into Azure, I'm gonna set up the location, I'm gonna create a resource group, make sure the resource group is there, and then one of the key things that you have to do when you're working with ACR is making sure that your Azure Container Registry's DNS name is unique, because it needs to be an internet addressable thing. It's globally unique within all of Azure and all of the internet. And so what I have here on line 56 is just some randomization, so when you run this, maybe you don't step on each other's toes. I learned that lesson the hard way. So 57 is for me, so Nocentino Systems 1, I create the container registry. There's different SKUs based on the capabilities of ACR that you need with regards to bandwidth, replication between regions, and things like that. And so if you're building production apps, look at the more advanced SKUs there. Once that's deployed, which takes a few minutes, we're gonna get the most important element out of all of that, which is our login server name. Our login server name is the address that we'll use for tagging, pulling, pushing, and where our containers actually live on the internet. So there we see Nocentino Systems 1, azurecr.io, okay? I need to authenticate to that container registry to push images to it. So that's what's happening here on line 69. So I created the container image up top. I'm gonna log into it so that I can interact with it at my command line on my local development workstation, right? That's what's happening here. I'm gonna skip past this part because it's not really crucial to the conversation, but you have the ability to get some performance metrics on things like pulls and tasks and things like that inside of ACR. If you didn't take note of, of the ACR login server name, I'm gonna extract it out because I'm gonna use it as an environment variable through the rest of the script, and so that's what's happening there on 71. Cool beans, cool beans. So with that, I now have a container registry. So now I have the leftmost part of that pipeline that we built. I'm gonna have a workstation, I have a container registry, and we're gonna do some more stuff. Cool. Let's see where we at. Yep, that's done. Who's next? Now, we're gonna get into the goods. We're gonna build containers. Also, questions throughout. If you guys have any, or if y'all have any questions, please feel free to interrupt and ask. So, again, this is intended to be completely reproducible by you all, so that you can run with it. So I'll give you the app. The app's just a simple VB.NET Hello World application. Ask me why I chose VB, because I'm funny like that. And what I have here is the average build start and time to retrieve first page, right? So to build this image, I've already pulled that 6 gigs of stuff. Just to build it from that takes another 2.5 minutes to 3 minutes. So we're looking at 13.5 minutes for a raw build if I don't have a cache layer. If I just type Docker run, 33 seconds, right? And the time to hit the first page, as we learned a few minutes ago, it takes about 20 seconds, right? It sounds fantastic for a DevOps pipeline, doesn't it? Because I use super advanced PowerShell techniques, you're gonna see me use things like measure command. I know. They keep inviting me back though, I don't know why. So this is a Docker file. And a Docker file describes what you're gonna build in a container image. And so the first is the thing that I pulled earlier, that big giant image, that's 6 gigs on my local hard drive. And that's gonna be what I'm gonna build my app on top of, right? So I have, which is, it's kind of cool if you think about it. Even though I'm dogging on the 6 gig size, I have an IIS web server, and it took me 1 line of code to get that. That's not too shabby, right? And that's why, like, I'm gonna try not to poo-poo on the technology, because I shouldn't. That's not an effective way to teach. But they're situationally appropriate. You choose your weapons when you have to build your things, right? But I'll make cheap pot shots as I can. I'm gonna set the working directory, which is where my app's gonna live. I'm gonna copy my pre-built application from my web app into the dot or the current working directory. When I say my web app, you'll have that code, so you can go repro this when you need to. After that, once my application is copied into the container, I need to execute some commands to set up that application in the IIS environment. So that's what's happening on line 4, where I am running PowerShell. I'm installing the ASP.NET framework. I'm installing the web ASP.NET feature, import module, web administration, so I can create a new web app on line 7. So I'm just building that thing all together, right? The simplest of applications. Still takes a lot of time. We'll talk a little bit about image layer optimization at the end, but just park this Docker file in your brain for that conversation. So we'll go through all that. I want to build that Docker image. That takes, once I run that, 2 minutes and 30 seconds, right? And that's with no image caches and all of that. So I tag that as my web app v1, and now I'm going to go and run that application, right? And I already let the cat out of the bag with regards to how long it takes, but that's going to take, 2 minutes and 27 seconds to build, and then it's going to take another 30 some odd seconds to run that app. And so let's get to that point where the app is running. So literally just Docker run, and I'm hanging out, right? Nothing's happening. It's just booting that environment up to get the application going. 30 seconds for that. And then I go and I hit the app, which is just, I'm going to hit it on localhost. I'm running that web server on port 8080 on index.aspx, 15 seconds that time. So all of our end users are 5 seconds happier than they normally are. So I'm going to delete that container. I want to tag that container on line 97, which will tag that so that I can upload it or push that into ACR. So Docker tag, my web app v1, my login server name, and then a tag inside of ACR, or that I want to tag the image as, and then push that into ACR here in a few minutes. So my container right now is 6.16 gigs just because I put a hello world application in there, right? Yeah, exactly. So push that up. Cool thing is Docker and ACR are smart enough not to have to move that 6 gigs into the cloud. It's going to take the layers that it doesn't know about and just ship those, right? So there are some efficiencies there with regards to the size. One of the cool things about Azure Container Registry that I like to use is this concept of an ACR task. So I can take, from Azure CLI, say ACR build image, give it a tag, give it a platform, and on the right, that period, which is the build context, is where the local Docker file is and all the code. And so what'll happen when I do this, it'll zip all of that up and just ship the code into Azure and build the container for me in ACR and push it so I don't have to push the whole image, right? And so that's a cool way to, like when you're building build pipelines, to remove the dependency on any local resources, just push all that into the cloud, right? So pretty cool technique there. So the next thing that we're going to do is the same thing as we did a minute ago for our v1 application. I'm going to create a v2 application. The only difference is hello world v1 now becomes hello world v2. Anthony does hello world at cloud scale, right? So same thing, but it's a little bit faster this time when I do this build. Excuse me. When I do that Docker build, it's a little bit faster because I already have some layers from the previous build that are available to me. And so we get a little better on the performance there. Same thing, this takes a whole bunch of time to start up, 25 seconds. And I go a little bit further, 15 seconds to hit that page, remove, I'm gonna tag it, push it. So this is literally rinse and repeat of the last demo. All right, so what we have now is ACR has both of my applications, v1 and v2, in ACR, Azure Container Registry, for me to build my integrations on top of, all right? Cool, I think we're doing okay on time. Okay. Who's worked with AKS or Azure Kubernetes Service? Okay, so AKS is Microsoft's managed Kubernetes service, and it's fantastic. I really enjoy working with it. It was a little rough in the beginning, but now things are pretty smooth with regards to how fast it responds to certain things that you want to do. Additionally, they're getting much better about getting newer versions of Kubernetes into AKS so that you can consume new features and techniques faster. That was one of my, not to say criticisms, but one of the things that I would discuss with customers is if you need a bleeding edge feature, AKS wasn't keeping up great. Now they're keeping up great, right? They're doing a nice job. Inside of AKS, you have the ability to deploy Windows nodes and Linux nodes. By default, if I just say, hey, give me an AKS cluster, you're going to get Linux nodes. There's a reason. Because, I know, it's too easy. So the core thing about AKS is really you don't have access to the control plane, but it is still Linux behind the scenes, right? A Linux control plane. When I say control plane, the services that maintain the cluster and stuff. And the coolest part about AKS is you don't have to worry about it. They do the backups, the replication, all that stuff to keep your Kubernetes cluster online. There's a concept of node pools inside of AKS, which just gives you the ability to aggregate or group like resources together or nodes together inside your cluster. And by default, you get a node pool. And then generally, with customers, will create new node pools if I'm moving between classes of nodes, like size. If I want to move to a bigger node and things like that. You can also use node pools as shift for application workloads. To deploy Windows nodes inside of an AKS cluster. You deploy AKS, you get a Linux node in a node pool, and then you get some Windows nodes in a node pool. So you have one Linux node hanging out, and then the actual Windows nodes that you need to do your workload in the cluster, right? So let's do it. Let's deploy AKS. Wait, hold on. I shouldn't say that after not traveling for like 2 years, right? Yeah, I'll deal with it. Where's the Claritin? I'll deal with it. All right. So now we're going to build an AKS cluster. Oh, pro tip. You can't have Windows in the name of your cluster, so I had to shorten it to Win. Anyway, AKS Win Containers is our cluster name. By default, every once in a while, AKS won't deploy the latest, and so generally what I do is I use this technique here on 128 to get the latest version of Kubernetes that's available to me when I build. Because when I build new stuff, I want to use the new stuff, right? Anyway, so on line 133, I am creating an Azure Kubernetes Service cluster, so AZ AKS create. I put it in a resource group, I give it a name. It has a node size of 1 for that one random Linux node. I'm enabling monitoring for performance monitoring. But the crucial part that you need to know is this part right here. The network plugin needs to be Azure. The default is CNI. That will not work. So you switch to Azure, and then you'll actually be able to deploy Windows nodes. And that's what we're doing on line 143 here, is AZ AKS node pool add. I'm going to add to my existing resource group cluster an OS type of Windows. I give it a node pool name and a node count. So now I have a cluster with 2 node pools, one with a Linux node, and another node pool with 3 Windows nodes, right? And so that's going to be the workload of my cluster. Does everyone understand what I mean when I say by node in a cluster, like what it brings to the party from a Kubernetes standpoint? Is anybody not hip with what that means? Cool, okay. All right, so once I have that cluster deployed, we're gonna jump forward, just make sure it's there. So that's what I'm doing here on line 151. It's just AZ AKS show. Does the thing exist? What we're gonna do now is something that used to be incredibly challenging and lots of bash expansion in Azure CLI, is I'm gonna give this AKS cluster access to pull from my Azure Container Registry. Service principals, all the fun stuff that we used to have to play with are now pushed into this command to make those two things work together nicely. Otherwise, you have to build authentication mechanisms and things like that in the Kubernetes tier. This is in the Azure tier. If you don't have kubectl installed in your platform, that's what I have here on 159, so that'll bring kubectl down for you. Kubectl isn't a thing. If we go to line 163, that'll pull the authentication credentials of the kubeconfig file from AKS to my local node. And again, before I move on to the harder stuff, I just make sure that I can talk to it, right? And so there I can see I'm doing a kubectl cluster info. I can touch it. I can see positive output that describes the AKS cluster that I just deployed. And we can see the topology of that cluster is the 4 nodes. First one being an Ubuntu 18.04, and then 3 Windows 2019 data center nodes that were all deployed just a few minutes ago. Cool. All right. Now, this is the important part. A label is a way for Kubernetes to give some additional metadata about a resource. And pretty much anything can have a label. And these are the labels that we get for free in an AKS node. And they give you a description of what that node does or has or its topology in your cluster. So for example, we see things like instance types, so standard DS2 v2, right? And now I know what its hardware profile is. I see region, central US. I see zone, zone 0. So I can get a feel for like what this thing looks like physically inside of an Azure data center. But the most important thing to this conversation is going to be a little bit lower in the output. I'm going to go down to right there. OS type here is Linux, so OS equals Linux is what we have at the bottom there, all right? Let's move forward and look at a Windows node, which will be right here. So there is one of the Windows nodes. If I go down a little bit further, we can see OS equals Windows, right? Because what we're going to need to be able to do is when I give workload to Kubernetes, I need to tell my workload a little bit about the topology. Because what would happen if I just scheduled a workload in this cluster, it would distribute it evenly across all of the nodes. How's that going to work out? Not so great. So we need to help Kubernetes understand what that looks like. And we'll look at that technique here in a few minutes. Cool. Where are we at? So, all right, so now we have our infrastructures laid out. ACR laid out. AKS up and running. Node pools are in the party. Windows is available. And so we know we have some potential challenges ahead of us. We know that we have a 6 gig container, right? In a modern data center, that doesn't sound too bad, right? To pull down 6 gigs, right? What do you have a 100 node cluster, right? That's gonna hurt because each node is gonna have to pull that thing. There are some tools and techniques to do some things that are a lot cooler to make that a little easier, but out of the box, that's gonna be a painful situation. We know our container startup time is not so great either, right? And so I'm gonna pull that thing down. It's gonna take some period of time, which I'm gonna show you in a minute. And then it's gonna take some time for that thing to start up. And then I have to hit the app, and then that's gotta work too, right? And so now, if I roll this out into my cluster with a traditional deployment, I'm gonna have this multi-gigabyte download across all of the nodes in my cluster, then I have to start this thing up, and then I have to send traffic to it, and what's gonna happen to that traffic that's gonna hit it? You're gonna wait, right? Or if the application isn't coded properly, whatever's hitting it's gonna crash if it's some sort of middle tier thing, microservice, yada, yada, right? We also have to be concerned about if it goes idle, right? What's gonna happen if it goes idle, right? Memory pressure, global assembly cache, and all those things could push out our compiled stuff and cause us lots of pain. Who's familiar with what JIT is, or just-in-time compilation? All right, so JIT compilation basically takes your binary object code that you get from a compiled thing like an intermediate or managed language like any of the .NET languages, and spits out this object thing which gets compiled at runtime, right? What does that mean for me when I'm deploying applications? Time, right? Because the user's gonna have to wait for my app to compile before it actually services the request. And so when I work with the developers to solve the problem of making their app compile faster, I'm not a developer. You know, I played one in 2008 for like 9 months. It was the ability to take that .NET application and actually fully compile it so that when it would hit, it would actually respond and not go through a JIT process. Yeah, so if I just roll this thing out, bad things are gonna happen. And this is what happened at that customer site. They rolled this thing out, and when they would start, the initial rollout went great. Everything came up after a minute. That's pretty cool, right? If you're used to that type of, or not used to that type of deployment mechanism that you get out of a deployment inside of Kubernetes. But what's gonna happen if I come along and I need to roll out V2, right? So I'm in production, I roll out V2, and I have to go through all this stuff again, which is gonna take time, which is gonna cause an outage, right? All right, so let's go look at the first deployment of our application on V1. Also, this is the very first time I've done completely recorded demos, so I should also tell you something.
They've gone very well.
Thank you. It's like flawless, exactly how I planned.
Temple gods are happy.
Yeah, and they're in Dropbox, so if this laptop crashes, I have another one. All right, so we're going to, again, you have all of this code. We're gonna roll out a service, which is an access entry point into my application. And so we're gonna deploy our service. Sorry, I had a little extra coffee and a little mouse jitters there. If we go down here, the service is of type load balancer. A Kubernetes service is an abstraction, a network abstraction for you to get access into the application that I've deployed. And so this is of type load balancer, which will actually provision an Azure load balancer with a public IP address. And so I'll send users to that public IP, and it'll get load balanced to all of the containers, all the pods inside of my cluster that are in the ready state, right? And we'll talk about container state in a few minutes. The deployment, standard deployment here, what I have, again, I'm trying to keep it super simple, 3 replicas. Now, this is the most crucial part of the deployment, right there, is this concept on line 17 called a node selector. And so now we have the label kubernetes.io/os and a value of Windows. And so this thing tells the Kubernetes scheduler to be like, you know what, only put this on nodes whose has a label of that, right? So now we can craft workload and get that to specific nodes into the cluster. And then on the bottom here, we can see my image is coming from my ACR, so Nocentino Systems 1, Azure Container Registry.io, and it's a V1 of our application. So if you do want to repro this, you will have to change that line of code to match whatever your container registry is. All right? Cool. Let's push that out. Service up and running. Our deployment's going to go. And so there, service created, hello world created, our containers are creating. So who's going to guess what's happening right now? What's happening right now? What's that? Yeah, it's pulling down the container images to each node in the cluster. So each node is responsible for a 6 gig transfer right now. 3 nodes, not so bad. 50 nodes, bad. 100 nodes, really, really bad. And so that takes Let's see, I'm moving ahead. I did not fast forward that. That takes 90 seconds just to pull the image, right? That's from ACR in a physically adjacent resource to the AKS cluster. This is all in central US, right? That's not fabulous, okay? All I've done so far is pulled the container within the concept of ready for a container inside of Kubernetes. By default, once the container starts, right, and it's running, I transition to ready. Is my app ready? No, but if I hit the load balancer, traffic is going to go to the pods, right? Yeah, exactly. So let's go ahead a little bit forward. My favorite command in Kubernetes, kubectl describe. If you do kubectl describe on whatever resource, you're going to get the gory details that us nerds generally care about when we're debugging problems. At the bottom of kubectl describe is these events. These events have a 1 hour life cycle, so they do roll off, so log aggregators are cool for that. But you can see it breaks down the phases of that rollout. So we see it gets scheduled to the node, it starts the pull process. That pull process takes 58.9 seconds. It takes 43 seconds to get the container up and running, and then for our actual application to get started, 19 seconds, right? That's a long time. And all the while, people might be trying to hit that application, and they're not going to get a response. So let's try to hit the app. And what I'm doing on 193 here is getting the service, loading that IP since it's dynamic into an environment variable, and then on 199, I'm going to hit it there with measure command, which again is the extent of my PowerShell abilities. And I'm kidding, I actually know PowerShell. That takes, surprisingly, 20 seconds, right? Exactly as we discussed. So, not really great from a DevOps standpoint because there's a lot of things that need to occur. So let's look at rolling out an application. So we can do better, right? We can use these things called startup probes and readiness probes. This is the second part of how I helped this customer solve this problem because they still needed to do this, right? As much fun as I am poking on Windows containers, we weren't going to change the code on like a Friday morning in Las Vegas. So it's like, how are we going to solve this problem? At the time, startup probes didn't exist. They didn't come out until like 2 or 3 versions later. So we had to make it work with what are called readiness probes. What a startup probe does is I can tell, or any probe, whether it's startup probe or readiness probe, I can tell Kubernetes a little bit about my application so that it can make a good decision on if my application is ready to respond, right? And there's 3 different types of probes. There's going to be TCP, there's going to be exec, where I can execute an arbitrary command inside the container, or HTTP GET. So I can test for a TCP port to see if it's running. I can run an application that could potentially do a health check inside my application, or I can hit a URL, right? And I'll respond based on the return code of the URL. So 200 to 2 or 399 is valid, and anything above 400 would be an error, right? So if the probe fails, then I don't transition into the ready state. If the probe succeeds, then I transition into the ready state. When I transition into the ready state, the load balancer sends me traffic, right? So now I know my app's up and running, and I can send traffic to you. And so we can combine probes with deployment rollout. So if I come along and I start swapping out all the containers for V2, what's going to happen is I can say, you know what, Kubernetes, don't shut this pod down until I have another pod in place that's up, running, and ready, then receiving traffic, right? So now I can actually roll my application out without having a downtime because I'm going to shut the container down, I'm going to start a new one up. Wait, oh, you're ready, boom, and then I can shut the next one down, right? And do it again, shut the next one down, and have an actual rollout that understands that. But I have to control that because I don't want to overcommit resources. This is another issue that this customer had, is they were using the default node size, which was 2 vCPUs and 7 gigs of RAM, and the actual memory consumption of their application was 3 gigs. 3 gigs, right? So how many pods could I run on a 7 gig node? 2, right? Interesting fact is Windows nodes have swap. Linux nodes don't have swap by default, and it's going to potentially have swap in the future. So it would schedule that next pod, and it would go above physical, and things would just start bombing out and failing and taking forever. Because what happens when an application starts, or when your base operating system starts swapping, the whole performance of the whole thing gets dragged down. And so we had to get that under control. So I was like, listen, Mr. CIO, please get your credit card out and buy bigger nodes. And he's like, I don't want to buy bigger nodes. I'm like, you have no choice, right? But max surge gives us the ability to control overcommitment of resource. So I can say only start up this many more pods. And so I can control how many more new things start up as I start shutting down old things, right? That's a way for me to control the commitment of resources. Max unavailable is a way for me to make sure that I can keep my workload consistent. So as I'm shutting down pods, I don't want to shut down too many pods and degradate my workload, right? And so these attributes would go in the deployment that I showed you all a few minutes ago, right around that node selector part of the code inside the deployment. So take these two things together, do the math on what's appropriate for your environment, your memory consumption, your node size, and things like that, and you'll be able to build a good, consistent rollout. Taking into account workload placement on the actual nodes that you build. If you have an application, I strongly encourage you to use what are called limits and requests. Limits and requests are in the container part of the deployment, which give Kubernetes some ability to understand the resources associated with your application. A limit is an upper boundary. It's a hard boundary, saying I can only consume this much memory. And a request is I need this much memory to start up. And so what would have happened in that scenario where that customer started up that nth pod on top of that node, that would have got it above physical. If I had a request and I said request 3 gigs, the scheduler would have stopped and said I can't find a place for this pod, and it would have protected the rest of the workload, and I wouldn't have started swapping, right? And so then I would have had a nice, I wouldn't have had a rollout, but I wouldn't have caused a bunch of issues in production and dragged down the workload, right? Excuse me. All right, so let's do container deployments in a better way. Ooh, I have no time left. All right, we're going to go a little faster just because of reasons. Because I want to go down all the nerdy holes, but I can't. All right, so all we're doing is rolling out V2. That's the only thing that's changed in this particular node, or this particular pod. And so what you notice, the key point of this demo right here is it starts creating that second container. This container pull will take less time because the majority of the image is already cached on the node, right? And so that won't take 90 seconds. It takes about 20 seconds to get that one up and running, 26 seconds. But that application's not responding properly, right? Even though it's the pod's up and running, the state skips right, there's no probes associated with this one yet. And so it starts shutting that one down. So now I have 2 pods that are not running because this one's not responding properly, that one's shutting down, and only one of these is servicing my workload, right? That could potentially cause some throughput issues in my application, right? Yeah, and we'll go through that real fast, and then it rolls it out. And then when I finally hit the app, 20 seconds again, because I rolled out V2. At one point in time, the best I was doing, I had 1 pod up and running that was happy, then I shut that one down, and then the next user comes along and I have to wait 20 seconds, right? Not a great place to be. So if I combine all the techniques that we're talking about with probes, what's going to happen is this. So I've added in the deployment underneath inside the container, because it's a per container thing, is I added a startup probe. So when I start responding to an HTTP GET on the base URL, I'm going to transition to the ready state, right? And then workload will start going to this. So that's going to solve the 20-second problem, right? And then I have a liveness probe. A liveness probe, if that fails, it'll bump the container. It'll restart the container. It won't delete the pod, but the container inside of it will kill it and restart it, right? So that's good if you have an application that just goes wonky and you don't want to troubleshoot it because you just reboot things. That's what we do, right? So that's going to restart the container. A readiness probe, these 2 probes, liveness and readiness probes, don't become active until the startup probe succeeds for the first time, and then it'll start checking these 2, okay? The readiness probe, after the fact, if I'm sending workload into it and that fails, it's going to pull that pod from load balancing. It's not going to terminate any existing connections, so if there's a long stream of traffic going into it, that's going to keep going, but any new stuff will get load balanced somewhere else. If this recovers and starts responding properly, then it'll go back to that node, right? And so a valuable technique of building self-healing applications. So let's roll it out. And so what we're doing here is I'm switching from V1 to V2, right? But with probes this time, V2 to V2 with probes, which is going to cause another container rollout. So if I do a get pods watch, what we'll see is running. It's running, but the container is not ready. It's 0 of 1. The startup probe hasn't passed yet. And so we know it takes about 30 seconds for the container, and then another 20 seconds for the app, and then it transitioned to running. Here, it transitioned to running. It's responding properly, then it shuts down the next one, right? So now everybody's happy, and the workload is getting distributed across the pods in the cluster. The rollout finishes and does its thing, okay? Now, this is, I actually intentionally have an error in here. This one right here. I am hitting this URL. So I'm doing measure command, invoke web request, and I'm hitting my web app index.aspx, and that took 8 seconds. Can anyone guess why that took 8 seconds? It should have, like, I'm like the first time I did, I'm like, it should take 0 seconds, right? Anybody want to take a guess? Bang, who said that? Yep, JIT compilation. So my probe is hitting the base URL, not my actual application, right? And so now, once I hit my actual application, that had a JIT compile and load, right? So Anthony, I did this the first time, and I was like, I don't know, and I thought about it for a minute, and that's what I came up with. So I wanted to leave that in so that you can kind of think about, like, when you are writing probes, they need to be intelligent probes that actually are meaningful to your applications, right? Cool. All right, so I have 1 minute, that's 8 seconds. I have 1 minute left. The last demo that I have is a .NET Core build of the same app. Who's going to guess what happens? Right? I'll do it real quick. Because I do have some stuff I want to talk about. So same app, .NET Core. It takes, I'll show you the output. It takes 37 seconds. And that's a multi-stage build. So that's the compile time of my app, like the build time, and the packaging into the container time. Where the previous version, I built that thing in Visual Studio and pushed the publish button to a file directory and just copied that in. So this is actually both phases, the build and the container build of my app. And then to hit that app, it takes 2 seconds, right? And then it took 3 seconds to start it, 2 seconds to hit it the first time, right? It's like eons of difference when it comes to the expectations that you have to do to roll out your application. Yeah, so just trust me that the push and pull and all that stuff works great. That's what I used to be a consultant. I would say that a lot. All right. Just trust me. Well, actually, you can trust because the video is in the GitHub repo, so you can watch it. Cool. So, again, I didn't want to poo-poo on the tech, right? Number one thing is super important, right? You don't have to change code. Because what's the most expensive thing in your data center, right? All of you all. So if you have to spend time changing code, that's going to cost time. It's going to inject risk into your environment. So, is that the right decision at the right time? Maybe long-term, I don't know. We talked about base image complexity a bunch. Size of container matters, right? This is a big deal when I have a 6 gig container and some number of nodes in my cluster. You can pre-pull all this stuff, and you can use some techniques to get those things closer to your applications or to your clusters, but it still takes time, and it adds complexity to the environment, right? If I have to do all this special stuff and remember to mash all these buttons and get this Rube Goldberg machine up and running to make sure my apps roll out, that's not great. Compile and build times can take a long time. Container and pod startup times become a big deal too, so you have to pay attention to that. App startup times aren't great, and it all kind of culminates in this, right? Deployment complexity. I like to keep things simple. I don't want to have to mash a bunch of buttons and knobs and use advanced techniques if I don't have to, right? Microsoft has a great article on image optimization. So the idea of building a container image in a Docker file for small layers and reusing layers is actually the most important part. Yeah, and so optimize the Docker files. Excuse me, I got that backwards. That's the listing of the base images. That's the Docker file optimization. And then, this is their best practices guide for taking what I'm talking about today, a traditional full .NET Core app or .NET application, and sticking it into a container. So they have a whole guide on that too. Yeah, and again, I think it's a workable solution, but you have to know where the bodies are buried, right? If you just walk out and try to do this, you're gonna, the stepping on the rake thing, right? You're gonna, so that's gonna be a challenge over time. Limits and requests, liveness probes, startup probes, or readiness probes are a thing, and it's getting better. Compilation times are getting better, images are getting smaller, and so it's not something that's idle. Microsoft is actively investing in this as an ecosystem or ecosphere, whatever the term is. And Linux containers can have the same problems, right? SQL Server is huge. It's 1.7 gigs, and it takes about a minute to start up. But still, I'm like a keyboard command away from a full functioning SQL server, right? Mark did it this morning. He forgot to start up his Docker container in his session, and boom, and he had a SQL server 30 seconds later, right? So that's still pretty cool. I like doing that. Awesome. So yeah, so again, this was real world stuff that I had to deal with at a customer site. We got them up and running. We did do all these things, but I kind of wanted to walk you through the whole process of building a container and what to look for in the Windows universe. If you need to kind of get into all this, please feel free to reach out. I'm on the Twizzles a bunch blog. I haven't blogged about this yet. I plan on doing it. This information, all the code and everything will be here. I'll also put it on the conference site. They'll probably be sad when I push half a gig of videos into the repo. And then I'm also a Pluralsight author. This isn't a sales pitch. I have all of this cool tech that I have courses on Pluralsight. If you want free access to this content, just shoot me an email and I'll give you a trial code. So if you want to get into the more advanced Kubernetes techniques and things like that, please, that's, again, not a sales pitch. I will give you free access to that stuff. So I am done. But if you want to have questions, I'll go outside if you want to chat more. So thank you all.